Next concept is mean absolute deviation. So what is deviation? Deviation is the distance between the value, okay, and the average. So x bar and this is xi. Your deviation is xi minus x bar. Okay. Now what we are doing is we are taking the summation of the absolute deviation. See, if you take just the summation of the deviation, it will be 0. Think as an example, you have values of 4 and 6. The average is 5. What is the deviation? Minus 1 here. What is the deviation? 6 minus 5 plus 1. Deviation is xi minus x bar. Xi is 4, x bar is 5. 4 minus 5 is minus 1. 6 minus 5 is 1. So if you take the sum of these two and the average, it is 0 by 2, which is 0. So the deviation sum is not good, but what we do is we take the absolute deviation. So that means we take the modulus of this. So it will become 1 plus 1, 2. This is the absolute deviation sum divided by the number of values. So the sum of absolute deviation divided by 2 is the average or the mean absolute deviation. So this is the better measure. So here what you are saying is how much they are deviating from the middle value. The higher it is, the more is the dispersion. Right? So higher mean absolute deviation is more. Okay. But one of the bad thing about the mean absolute deviation is to take the positive value, you have taken the modulus. So this is not very much useful when you are doing the differentiation. Note that differentiation of something to the power x is constant and the second order differentiation will be 0. Okay, but we are many times required to do the second order differentiation. So what we require is something which has a power. So x square, if you differentiate first time, it is 2x. The next time you differentiate, it is 2. To find out the maximum and minimum value, you need to differentiate 2 times, right? So this is not a good measure. Okay, we want something which will make it absolute, but it gives a it makes it from the square. So we have another term which is your variance. So in the variance, what we do is we do the average square deviation from the mean. So we take the summation, okay, to make the positive we do the square, okay, and then we do the n. Okay, this square is useful for the differentiation purpose. Okay, now variance are two variances are there, population variance and sample variance. Note that the population variance formula is different than your sample variance formula. In the population variance, we divide the values divided by n. Okay, and mu is your population mean and n is, remember I said that n is big and you should use for the population, and so xi minus mu whole square divided by n, where n is the number of terms, right? Whereas in a sample variance, you don't divide by all the number, you divide by n minus 1. Now why it is being done? Please note that what happens is this x bar is not equal to mu. Okay, as a result there is a slight underestimation if you divide it by n. Okay, right? So you make the sample variance smaller, right? So to make it unbiased, to get an actual value, what we do is we adjust this, okay, denominator. It is adjusted, it is divided by n minus 1. So this becomes lesser and your sample variance becomes higher, right? So there is also statistical logic about it. We are not going to cover it, but what we are saying is population variance you divide by n and your sample variance you divide by n minus 1, right? So this is a variance.